So today we're going to be getting the Algebra 2 Semester 2 exam review. Now this is going to cover all the problems listed in the exam review, and we're going to be using the following formulas are going to be at our disposal. We have things like the quadratic formula, standard form, probability. We have some aspects of standard deviation. We have series notations and summations of series, and the logarithmic change of base. This is going to be 8 pages long. Each video is going to comprise of a small portion of the set of questions. So without further ado, we're going to go ahead and get started on the first column. Following videos are going to follow up on columns that come adjacent to that. So to start off, we have question 1, which is what is the y-intercept of this equation? So on questions like this, let's go ahead and zoom in. So for question 1, we want to find the y-intercept of this. We have y equals 8x plus 4 over x minus 1. And we know that to find the y-intercept, we simply plug in the value for x. And at the y-intercept, x is going to be equal to 0. So I'm going to plug 0 into this equation, which is going to be 8 times 0 plus 4 over 0 minus 1. Okay. And as we evaluate this, 8 times 0 is 0 plus 4. 0 minus 1 is negative 1, which means the y-intercept is negative 4, but we don't write it as negative 4. We show the y-intercept at 0, negative 4. And that is our answer. Okay. For question 2, we have the following statement. Given f of x equals x squared plus 2x minus 48, identify the following. Vertical asymptotes, horizontal asymptotes, removable discontinuities, or holes in the graph. And then for the honors portion of the course, we want to find x-intercepts and the domain. Now, typically the domain is going to be listed in interval notation, so let's go ahead and jump into this. So we're going to start off with writing out the problem. We have f of x is equal to x squared plus 2x minus 48 all over x plus 8. Okay, so the name of the game with these problems is going to be factor, factor, factor. For the next few questions, it's going to be factor everything that you can. We notice the top is a quadratic with no coefficient in front of the x squared term. So we can simply read it as what numbers multiply to give me 48, but when I subtract them, give me 2. And that's going to be an x plus 8, x minus 6. 8 times negative 6 is negative 48, but 8 minus 6 is going to give me a positive 2. Combine that with the bottom, x plus 8. And we see the fact that we have an x plus 8 on the top and bottom. This is going to clue us into one of the 3 things that we need to list on this problem. We want a vertical asymptote, we want a horizontal asymptote, and we want any sort of removable discontinuities. Well, for right here, what would have happened if I tried to plug in a negative 8? Negative 8 plus 8 would be 0. I would have a number divided by 0. I can't have that, which would normally be a vertical asymptote when I try and divide by 0. But because it did cancel out, it's not an asymptote anymore. It is removable. So for my removable discontinuity, let's do this in, let's do it in green. So for my removable discontinuity, I know x can't equal negative 8. Normally it would have been a vertical asymptote, but now it's removable. In that case, there's no other numbers that I could divide by that would give me a 0, so I know there is no vertical asymptotes. Furthermore, because there's no numbers that I'm dividing by in this case, my equation is now just, let's rewrite this, f of x is equal to x minus 6, which we know this is a line. A line has no horizontal asymptote. In fact, the farther out we go, it just goes either up towards positive infinity or down towards negative infinity. So there are no horizontal asymptotes. For the honors portion, we have 2 things that we need to find. We need to find the x-intercept, and we need to find the domain. So the x-intercept, what we're going to do is we're going to set this equal to 0. Because remember, for the x-intercept, I plug in a y of 0. Y of 0 is going to replace my f of x. So let's go ahead and figure out what that would be. And I plug in a 0 for the y. And this, I would just add the 6 over here. I would get 6 is equal to x. My x-intercept is 6, 0. Awesome. For the domain is asking us all possible values that we can plug in for x. Well, we know that we can plug in any number we want outside of the removable point of -8. So we can plug in any number from -infinity all the way up to -8. But I cannot include -8. So I'm going to bracket that with a parenthesis, comma, -8 all the way to positive infinity, which means I can plug in any number I want minus the point of -8. And there we go. That's interval notation for the domain. Okay. So now we have that. Let's take a look at the third question. The third question says, given f of x equals a very similar style question, identify the following. Same 4 setups: vertical asymptote, horizontal, removable discontinuity, and for the honors portion, x-intercepts and the domain. So let's go ahead and transcribe this right here and check this out. Perfect. Now we have everything that we need. So again, when we see setups like this, these are rational equations. The name of the game is factor, factor, factor. So what I'm going to do is I'm going to factor the bottom. This is a difference of squares, which I know. Actually, let's set up a divider right here. That divides that. That divides that. So the bottom being a difference of squares, I can factor this into the root plus the root, root minus the root. The root of x squared is x plus something, x minus something. The something that we're adding and subtracting is going to be the root of 9, which is going to be a 3. The part that's going to take an extra step to work through is this part. So let's do this in purple. To factor this out, I'm going to have to figure out what factors will give me this middle term. And I'm going to do factoring by grouping, which means I take the 3 and the -12, and I multiply them together. 3 times -12 is -36. Because that is a negative number, I'm going to try and find the difference between all of these factors. And I'm going to list every single factor of -36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I'm going to find the difference between all of these. So 35, 16, 9, 5, and 0. And I'm trying to find ones that make a 5. So I found them right here. I know that this particular numerator can be split up into this expression, 3x squared. Let's see, I have a 9x and a 4x that I need to make a -5. So it's going to be minus 9x plus 4x minus 12. So now that I've split this up into 4 terms, I'm going to group them, which means that, let's do this in blue. Factor out the GCF of the left and of the right. 3x and 4. If I factor 3x out of the first 2 terms, I will get a x minus 3. And if I factor a 4 out of the right 2 terms, I'll get an x minus 3, which means my 2 factors are going to be that x minus 3 that they both share, and then the 3x plus 4. I'm going to go ahead and write that down right here. So x minus 3, 3x plus 4. Okay. Now that I've factored out this problem through factoring by grouping, I'm going to go ahead and eliminate what I can, where I can. In this case, the x minus 3 gets canceled out. Nothing else does. So as far as my vertical asymptote, my horizontal asymptote, and my removable discontinuities, I just removed one value for x that would have normally produced an asymptote. So I'm going to say, what value for x would I plug in to make that a 0? X can't equal a positive 3. For my vertical asymptote, any values left that I didn't remove that would make the denominator equal to 0 is a vertical asymptote. So that would mean x can't equal negative 3. The horizontal asymptote is built in one of two different ways. The first way, because the equation that we have left is 3x plus 4 over x plus 3, is I want to figure out what happens as I move farther and farther towards infinity. So I'm going to start by plugging in a value like, let's say, 10, and move over with each successful term from 10 to 100 to 1,000. So as I get closer and closer towards infinity, what is y doing? And there's two ways to do this. So we can either do this via the brute force method, which is when we plug in a table. And the way we do that is, let's actually set this up right here, is I will take my actual equation and I'll take it, go to my y tables, open parenthesis for numerator, 3x plus 4, close parenthesis, divided by denominator of x plus 3. This gives me my equation. I'm going to come over here to table, so second table, and I'm going to plug in values that slowly get bigger and bigger. So 10, my y is equal to 2.61. If I plug in 100, I'll get 2.95. If I plug in 1,000, I'll get 2.995. And so we notice that the graph seems to be approaching a value, but let's plug in a really big number. How about 100,000? I think that's a million. Let's plug in a million. And so what we notice is that I have 2.9999950000002, which the calculator rounded to 3, which kind of allows you to cheat and see where this is going to go. So when I plug in a million, 2.999, and it keeps going. So what value is this graph approaching as we get towards infinity? Well, y is approaching 3. There's my horizontal asymptote. The other way to do this is to simply look at the ratio of the coefficients of the largest power. If we look at our original question and we say, hey, the largest power I have here is x to the first. Well, I have a coefficient of 3 on the top and 1 on the bottom. What is 3 divided by 1? 3. No table needed, no calculator needed, no evaluation needed. And for the honors portion, we have 2 additional questions. We have, where did I place the paper? We have what is the x-intercept and what is the domain. So let's take a look at those 2. So as far as the x-intercept, we've talked that the x-intercept means I'm plugging in a value of y is equal to 0. So I'm going to set this equal to 0. Is equal to 0. Okay. So for my first step right here is go ahead and multiply both the left side and the right side by x plus 3. Now if I multiply the left side by x plus 3, let's actually show out this step. X plus 3, x plus 3. We see that they cancel out over here on the left. We also notice that 0 times anything is still 0. So what we're left with is 3x plus 4 is equal to 0. In this case, we just go ahead and solve the equation. Subtract 4 and divide by 3, which means my x-intercept is going to be negative 4/3, comma, 0. For the domain, we're going to list all values of x that we can plug in, which means I'm going to have to come up here and look at two of my limiting factors, any vertical asymptotes and any removable discontinuities. What can x not equal? -3 and +3. What can it equal? Well, anything else. So from -infinity all the way up to -3, from -3 to 3, and from 3 all the way to +infinity. Any value we want other than -3 and +3. Perfect. And so now we're going to take a look at the next one. Number 4 says, given a very similar value, or very similar expression, calculate the same set of values. So let's move on to a new sheet of paper. Copy down this question. Okay. Again, the name of the game is factor, factor, factor. So I'm going to factor out a 2 on the top and get x plus 1. On the bottom, because there's no value for a in front of the x squared, I'm going to say what numbers multiply to give me 2 but add up to 3. Well, that would be 1 and 2. Then I notice that I have an x plus 1 in the top and in the bottom, which leaves me with a value of 2 over x plus 2. This gives me all the information I need. For the vertical asymptotes, the horizontal asymptotes, and the removable discontinuities. Well, the removable discontinuity is right here. What value can I not plug into x but that I removed? That would be a -1. What was left behind is this. If I plug in a -2, I'll divide by 0. So for my vertical asymptotes, x cannot equal -2. The last thing is the horizontal asymptote. We have two choices. I can either build the table, which means that I would plug in numbers larger and larger and larger and larger, or I can read the ratio of the coefficients. Now, two things. This one doesn't look too obvious because I have an x on the bottom, but I have no x on the top. But let's rewrite this in a way that might make more sense. How about let's rewrite this as a 0x? And then ask yourself, does that help? Well, if you're using the shortcut, you should say yes. In fact, the coefficients in front of the x terms are a 0 on top and a 1 on bottom, which means y will be approaching 0 divided by 1, or y will be approaching 0. If you wanted to build yourself a table, no worries. Let's go ahead and let's clear out all of our old data, clear this out, and build that function. So 2 divided by parentheses x plus 2. Come over here. Let's plug in bigger and bigger numbers. We have a value of 10, 100, 1,000, 10,000. What we notice is it went from 1.6 to 0.19, or 0.019 to 0.02 to 0.0002. We notice that it seems to be the numbers are getting smaller. So what happens if I plug in a number like that? Well, I'm left with even more decimals. So we know that it is slowly approaching 0, no matter if we use calculator or table, or rule or table. The two parts that we might want to work are the x-intercepts, which means I will plug in a value of y is equal to 0. Equals my value of y of 0. And then what I notice is that, okay, if I go to multiply both sides, that x plus 2 cancels out. I have 2 equals 0, which is an untrue statement. Which means there are no x-intercepts. That makes sense because where on the graph does it intercept the x-axis? Well, when y equals 0. And we know from the horizontal asymptote, what does y not equal? 0. So there's no x-intercept because y will never be what it needs to make it intercept. And the last thing is the domain. So the domain is any values that I can plug in for x. Well, looks like I have removable discontinuity 1 and asymptote number 2. So anything that is not a -2 or a -1. So anything from -infinity all the way up to -2, from -2 to -1, that's okay. And then from -1 to infinity, that's okay. Perfect. Okay. So now we head off to a different style of question. Now this is more arithmetic. The next 4 questions are going to be covering not what aspects of the graph are we looking at, but what do we need to do arithmetically. So let's go ahead and separate ourselves a new question. Okay. We want to simplify number 5. So we get this. That is a 4. So again, the name of the game on these is factor, factor, factor. The top is a quadratic. What numbers multiply to give me 20, but when I subtract them, give me 1. That's going to be -5 plus 4. The bottom difference of squares, that's an x plus 5, x minus 5. Secondly, I know when I divide by a fraction, I am really just multiplying by the reciprocal, and I flip it. Now that I have factored, the name of the game is reduce. -5's on top and bottom, +4 is on top and bottom, and that is it. Perfect. Separate our line. If I look at the next question, I'm going to do the same thing. Okay. Now that we have the question written down, let's go ahead and factor, factor, factor. The first term is going to come down to an x plus 3, x minus 3. The lower term, because there's no coefficient, what factors of 21 multiply to give me a -21, but when I subtract them, give me 4. Awesome. And now the top, even though this is a binomial, I can still factor this because I can pull out, both these terms have at least 2 x's. So I can pull out an x squared, or if I want to rewrite that as an x times x, which is an x squared. That'll leave me with an x minus 4. On the bottom, I can't pull out 2 x's, but I can definitely pull out 1 x. I'll be left with x minus 3. Now that I've done that, the name of the game is reduce, reduce, reduce. Make sure that is a -4, yeah. Yep. And so that is going to be it. Double check. Oh, that is an x plus 3. Silly goose. It's going to be 7 times 3 is 21, not 7 times 4, which allows that x plus 3 to also cancel out. And we're left with this expression. Which, if we distribute that x into there, x squared minus 4x, x minus 7. Boom. Okay. Now that that's done, take a look at number 7. Okay, so when we get this value, we notice they're both over 5, so I can go ahead and combine the tops, and I'll be left with a 6x plus 8 minus 2x minus 10 all over 5. If I distribute that negative sign, that will give me a 6x plus 8 minus 2x plus 10. Awesome. And so now it just comes down to combining like terms. I have my 6x minus 2x, and I have my 8 plus 10. So 6x minus 2x is 4x, 18 plus 10 is 18. Perfect. Okay. So that leads us to the last style question. Number 8. I have an x minus 5 over 7x squared plus 4 over x minus 6 over 2x. I want to simplify this. Okay. So the first thing you should notice is that 6 divided by 2 reduces down to a 3 over 1. So it's really x minus 5 The next thing that we do is we know that we're adding or subtracting fractions. I need to have them with a common denominator. So the first thing I'm going to do is I'm going to go ahead and find out, do they all have a 7? The answer is no and no. So I'm going to multiply top and bottom by a 7. The next thing I'm going to look at is, do they all have an x squared? Almost. Well, I have an x and an x. So how about an x squared? Oop. How about an x? Which x times x will give me an x squared. Perfect. So in this case, I have an x minus 5 plus 28x minus 21x. Okay. So let's go through and let's combine what we know. I have an x plus 28x minus 21x. So x plus 28 is 29, minus 21 is 9, 8, 8x minus 5, all over 7x squared. Perfect. And there we go.